Hello everyone, this is Amit Ghai, your Six Sigma Black Belt coach and mentor. In today's video, we are going to talk about failure mode effect analysis, in short, that is called FMEA. So let's deep dive. The objective of the FMEA is to identify, mitigate and prevent problems or failure from occurring in a product, service or process design. We aim to facilitate the team to build a problem statement that focuses on the most significant areas. Now let us take a brief look at the history of FMEA. The concept of FMEA was introduced in aerospace industry back in 1960. It was a revolutionary approach to predict and prevent potential system failures. In 1974, the United States Navy adopted this methodology and incorporated it into their MIL standards. This further validated the effectiveness of FMEA in managing risks and improving the reliability of products. By the late 1970s, the automotive industry began to see the value of FMEA. It was driven by increasing liability cost. Automotive manufacturers started to apply FMEA in their design and manufacturing processes therefore. This marked a significant milestone in history of FMEA as it expanded beyond the aerospace and military application into the commercial industries. In conclusion, FMEA has proven to be an invaluable tool in various industries for over half a century. Its ability to identify potential failures before they occur has made it cornerstone of quality and risk management across the industry, either it being manufacturing, service industry, banking, or any other area. So let us see, where do we use FMEA? It is most effective when it is used in measure, analyze and improve phase of a Six Sigma DMAC project. It's crucial to implement FMEA as early as possible in product or process lifecycle. Why this timing is important? The answer is simple. It saves money. By identifying and addressing potential failures early on, we can avoid costly fixes down the line at the later stages of your process design. Now, why should we use FMEA at all? There are several reasons for that. Firstly, FMEA expands the team's thought process, encouraging a more comprehensive approach to problem solving. Secondly, it helps identify area where efforts should be concentrated. It ensures that your resources are used efficiently. And lastly, FMEA provides design or improvement guidance that helps the team making informed decisions. FMEA is used to evaluate the process from the customer's point of view. This customer-centric approach ensures that our product or services meet or exceed the customer's expectations. So, the intent of FMEA is twofold. Number one, to identify the potential failure modes with causes and effect relationships. And second is to prioritize efforts to eliminate potential failures from the process. By doing so, we can enhance product quality, improve customer satisfaction, and ultimately drive the business success through well-efficient processes across the industry. Let us look at how does the FMEA works. FMEA is a systematic approach to identify potential failure modes within a system broken down by each process steps. These failure modes then are classified based on the severity of their effects, that is here on our screen. Next, we identify the cause of each failure. They may be the tentative cause at this moment, and then we actually evaluate the frequency of each of the cause. How often that problem happens by the certain cause. The next is to identify the current controls. The current controls are the one, at this moment, do we have any sort of mechanism to prevent these problems or not? And then we do the rating on the modes of detection. Finally, we do the risk analysis by calculating the RPN or risk priority number. Later on, in the improved phase of the DMAC, we identify and implement the corrective actions accordingly. So let us look at step 1. Completing an FMEA comprises not only filling out the actual form but also consists of planning with a pre-planning team meeting. So the planning consists of the bulleted items here. Number 1 is determining the scope of the discussion. Which area of our process we are going to discuss. Number 2, identify the appropriate resources, those have enough knowledge about those particular process steps. Review drawings and specification to look into the specification those are inherent into your product. Then we move to review related design FMEA or quality function deployment or QFD if possible. Then the team together discusses the analyze process flow diagrams. We look into the overall end-to-end structure and the sequences of the process. Then we analyze the product histories, if there were certain changes made, what were those revisions, and then create a plan and a schedule. So plan is the step 1 of FMEA, where we actually do the planning about the project team and the process on which we are going to conduct FMEA. Here is the step 2 of FMEA process. Brainstorm and measure. In this crucial step, here the teams gather to brainstorm and measure potential failure modes, a step best performed face to face with a skilled facilitator. Let's dive into the key activities of FMEA measure phase. First of all, list all the process steps on the form. The visual representation is important for a clear understanding of the workflow. Next, engage the team in brainstorming sessions over the meetings. During these discussions, identify potential failure modes for each and every step. Group these failure modes by type or area or failure within the process. It's vital to combine similar failures but exercise caution not to merge failure modes that can occur on multiple steps of the process. After identifying failure modes, determine the effects of each failure on the overall process. Understanding the impact it could have on the workflow and product or a customer satisfaction, this comprehensive analysis is crucial for accurate risk assessment. Now comes the critical step of rating the severity of each effect. Typically a scale of 1 to 10 is used, with 1 indicate the minor impact and 10 is a significant impact. The rating system helps team prioritize which failure modes demands immediate attention and mitigation strategies for the long term. Imagine a scenario where a failure mode could halt production itself. That leads to a significant financial losses for the company. Such a situation would likely be rated closer to 10 on the severity scale. On the other hand, a minor glitch that only slightly inconvenience the process might score lower there, perhaps a 2 or 3. The next important step in the FMEA process is determine causes and detectability. In this phase, our focus sharpens as we delve deeper into understanding the root causes of identified failures and evaluate our ability to detect them. Let's explore the key activities in this critical stage of FMEA process. Firstly, it is crucial to determine the specific causes for each failure. Avoid the vague statements like machine error, human error. Instead, pinpoint the exact factors within the process or design that lead to the failure at this stage. To be specific here, it is important to allow for precise problem solving and effective countermeasures. Use the tools like fishbone diagram or YY analysis for this step. Next, for each identified failure, rate the frequency of occurrence at the scale of 1 to 10. This numerical rating provides valuable insights into how often a particular failure is likely to occur. A high score indicates a frequent occurrence demanding urgent attention and mitigation plan. Next, assess the design or process controls in place for each of these causes. Determine if the cause can be controlled, and if not, evaluate if the failure can be detected in current system and how. If the failure is not currently detected, brainstorm on methods to identify it. The proactive approach ensures that the potential failures are caught before they escalate and prevents costly consequences down the line during your production or the services. The next one is to rate the probability of detection on a scale of 1 to 10. This rating reflects how likely we are to detect a failure before it impacts the process or the end product. A high score indicates that the problem is tough to detect and most likely is going to impact the customer, whereas a low detection score indicates the problem can be detected upfront during the process itself. In essence, the determine causes and detectability phase is about precision and the vigilance. By identifying specific causes, evaluating their frequency, and enhancing our detection capabilities, we build robust barriers against the potential failures here. It ensures the smooth flow of our processes at the later stages. The contents of the FMEA form is divided into the various sections. You will fill out the header information first. Next, you will list the items or process steps that will be analyzed, the potential failure modes of those items or process steps, the potential failure effects of those items or failure modes, and how severe those effects are to the end user will be filled then. You will also identify the potential causes of the failure and will determine the likelihood that cause of failure will occur. You will list the current controls that will either prevent or detect a potential failure and how effectively those controls are detecting the potential failure modes. With that information, you can calculate your risk priority number. Once you list recommend actions and who is responsible for implementing them, you can then revise your FMEA with the new severity, occurrence and detection values. This will ultimately change your risk priority number. In each section, number is named. It appears. Now let us look at the detailing of each of these columns. The column number 1 is process step or function. Here you will enter a description of the part or process that is being analyzed. The question to ask yourself at this stage is, what is the part or process supposed to do in view of customer requirements? Make sure you use simple, concise words such as receive parts or wash parts here. If the system components or process involves functions with different potential modes of failure, such as caliper check, list each function separately. So you can have repetition of the steps here if you have the multiple failure modes at this step. Remember to consider unintended function of the item or steps beyond the process, such as transportation to the customer, customer storage, etc. They can be ignored here. After you describe the design or process, then you begin to brainstorm potential failure modes. A potential failure mode is defined as the manner in which a system, subsystem or component could potentially fail to meet the design or the process requirements of the customer. The question to ask yourself at this stage is, how could this design or process fail to meet customer requirement? For example, customer is calling you, your telephone is ringing, but nobody is picking it up. Some example of potential failure modes are also deformed parts, improper seals, loose covers. In the example, a potential failure mode of the rinse system is not using the deionized water during the rinsing. So all of these are potential failure modes. If you find a failure mode, the next question to ask are, what would be the result of this mode of failure? What will be the impact? How does the product or process fall short of the customer expectations? Your answer those questions by determining the potential effects of the failure mode and describe the effect in terms of what the customer might experience or notice, such as noise, fumes, leaks, non-responsiveness, erroneous report going to the customer, erroneous transaction, the effect of not using deionized water in the rinse system, like I said earlier in the example, it would be the plating or sputter adhesion. It means it will not meet the customer's requirements. Remember, the customer may be anyone, an operator, the next process operation, an assembly plant, or a distributor, and the end user also itself. After listing the failure modes and effects, you must determine how severe those effects are. Severity is defined as an assessment of the seriousness of the effect or effects of a potential failure mode on the next component, subsystem, system, or the customer. Can it cause a harm to the customer, or it will leave unresponsiveness from the team and customer dissatisfaction? What kind of impact it will leave on the customer? Severity applies to the effects. A reduction in severity ranking can be affected only through a design change. Severity should be estimated on a 1 to 10 scale. For failure mode with multiple effects, rate each effect and select the highest rating as the severity associated with the failure mode being analyzed. So we will see more details about the severity rating very soon. Here are the table or the guidelines that would be used to determine the severity of the potential effect of failure. If you see here, 1 is given to the none. It means if the problem happens, it will be unnoticed and will not affect the performance. And 10 is hazardous without the warning. It may injure a customer or the employee. And then we have 5 and 6, that is moderate or low in between. I will always recommend to use these guidelines to mention in your FMEA. Do not pick the random numbers here. Now let us move to the next column of FMEA sheet, that is causes of failures and the occurrence. The potential causes of failure are identified. This refers to all the things that may be responsible for the failure mode or how the failure could occur. Potential causes of the failure could be any design weakness or the process changes or variables. Once the potential causes of failures are identified, then probability of occurrence is ranked. Occurrence is determined or defined as the likelihood that a specific cause or mechanism will occur. Removing or controlling the cause or the mechanism through a design change is the only way a reduction in the occurrence ranking can be affected in design FMEA or DFMEA. The likelihood of occurrence is ranked from 1 to 10 scale, where 1 is the lowest and 10 is the highest. These are the occurrence guidelines as determined by FMEA, where 1 is very remote occurrence, where failure is unlikely, PPK is smaller than 1.67. If I look at the Six Sigma side, once every 6 to 9 years. On the other hand, the 10 is very high, persistent failure, PPK is less than 0.55, more than once per day. Based on these ratings, you need to select a number between 1 to 10 based on how often a particular failure happens in your processes. Then we move to the current controls and detection. Current control is the next section of the FMEA form. Here the controls are listed that will prevent a failure mode from occurring or detect a failure mode if it does occur. Example of current controls could be preventive maintenance procedures, job aids, inspections, audits, or tests. Detection is the next. Detection is the ability to determine if those current controls would actually find a flaw or failure mode before the component, subsystem, or system is released to the production or a transaction is booked in the system. Like severity and occurrence, detection is related to 1 to 10 scale, from 10 being unable to detect potential cause of failure and 1 is immediate detection of potential cause of failure. Do not assume low detection rating because occurrence is low. For instance, a potential cause of failure can happen very infrequently, but when it does occur, there is no way to detect it. A low occurrence rank does not necessarily result in low detection rank. Nor does a low detection rank necessarily results in low occurrence rank. So occurrence and detection are not directly linked to each other. The likelihood of an occurrence can be very low while the ability to detect the occurrence can be very high. The combination of ranking between occurrence and detection are possible. I can give you an example. For the low fuel in your car, you will have very high detection because simply by looking at the gauge you can detect it. And occurrence, it is pretty low because you often fill your tank. So occurrence and detection, they are linked to each other in a way that one of them could be low, another one of them can be high also, and the vice versa also may take place. Here are the detection guidelines. This table will be used to determine how likely the current controls will detect a potential cause of failure. The one is very high, it controls certain to be detected. It means whenever the problem will happen, immediately it will be detected. And 10 here is the defect caused by the failure is not detectable and most likely it is going to be passed through the customer. Then the step 3 of the FMEA is to calculate the initial risk priority number. RPN is used to prioritize the concerns. The RPN is the result of multiplying severity with the occurrence and the detection. Higher RPN values should be indicating the cause for the greater concern. A high number in any one of the ranking, occurrence, severity or detection, could indicate a need for immediate action. So by multiplying all three of them, we come to know the RPN or risk priority number. So RPN is like a coefficient on a linear equation. It determines the strength of relationship of cause to an effect. So the question here is, how do we decide what to work upon? Because we have already calculated the RPN, then we should rank the RPN score from highest to lowest. Work on anything with a severity score of 10 because it is an immediate concern for our customer. Look for the large break in the RPN score where we have very low versus very high RPN numbers, or you may also apply the 80-20 rule or Pareto rule to work on the top 20% of the identified issues here. Now let us look at the step 4 of the FMEA process, corrective actions. This phase marks a crucial turning point where the insights that we have gathered from the previous steps are transformed into the proactive solutions. This ensures the continuous improvement of our processes. Let us explore the key activities in this stage. First and foremost, it's time to brainstorm potential solutions to mitigate the priority cost identified earlier with the highest RPN. At this stage, think creatively and work collaboratively. Encourage the different perspective to generate a comprehensive list of the solutions. And remember, the goal is to address the root causes effectively. Once the solutions are generated, it is essential to prioritize them. Not all the solutions are equal. Some may be having more significant impact on reducing the risk. Prioritization helps focus resources and efforts on the most critical ones. It ensures a targeted and efficient approach of the team. With the priority set, next is the time to implement the chosen solutions. This step demands coordination, communication, and dedication of the team. Implementing solutions might involve process modifications, training programs, or even the technology changes. Whatever the solution is, it must be executed diligently to ensure that it is effective and reducing the RPN. After implementing, it is crucial to reevaluate the risk priority numbers. The reassessment provides concrete data on the impact of the implemented solution. Ideally, you should be observing a reduction in RPN values. That indicates that the corrective actions have successfully mitigated the risks those you identify. Let us imagine a scenario where production line face frequent line stoppages because of equipment failures that was resulting in high RPN values when you did the previous steps. But after implementing the preventive maintenance protocols, employee training programs, the frequency of failures reduced significantly. Eventually, this will decrease the failures and it will be reflected in the lowered RPN values, showcasing the effectiveness of the corrective actions. So in the summary, the corrective action phase is about proactively addressing the issues, learning from them, and making the process fortified against the potential failures. By brainstorming, prioritizing, implementing, and evaluating the solutions, we pave the way for enhanced efficiency, quality, and reliability in our operations. As recommended actions are implemented, the severity of potential failure effects, the likelihood of occurrence, and the ability to detect errors can be recalculated. For those new values, a new resulting RPN or risk priority number is then determined. If you are able to show a significant reduction in RPN, your FMEA activity is considered to be successful. Here we do see an end-to-end FMEA implementation. On the left side of the form, we do see process steps, failure modes, root causes, and resulting RPN number. We do calculate the RPN first at the analyze phase of the Six Sigma DMAC project. Later in the improve phase, we do mention the recommended actions, responsible person or department, the target completion date, and finally the actions taken. After completing these implementation, we do recalculate the RPN and compare it with the original one. The revised RPN is calculated in the improve phase. Let us now look at some of the examples and case studies. In the automotive industry, the FMEA is used to minimize the risk of brake failures from overheating or malfunctioning. In aerospace industry, for the aerospace industry, FMEA is used to prevent the system and the product failures, everything from engine to navigation system. When we talk about healthcare, here also the FMEA can be used to identify, assess and prioritize potential risk and failure mode in medical devices, facilities and system to improve patient care. In the service industry, it can be used to enhance customer satisfaction. It may ensure the consistent service quality, reduce design, change and transaction cost, and minimize the liabilities to the company. So we can see here that FMEA can be used across all of the industries. So in conclusion, FMEA is a powerful tool. It has the far-reaching applications across all the industry. With the proper training to identify, assess and prioritize the potential failures, use suggested solution and take corrective action, it can help prevent costly system failures while continually improving the quality and reliability of the product and the services. I hope you find this video informative. For more such video, please subscribe to my channel Sigma Savvy AG. The link of that is mentioned.